Question 7 states, find the equation of the following polynomial. Now, what we're going to do is very similar, take very similar steps to what we did last time, where we take each of the solutions. We can see that that solution there is x equals to -1. This one here is x equals to 0. That one there is x equals to 3. And so what we're going to just write down, I guess we can just write down the solutions here, if it makes it easier. Okay, the solutions need to be converted into bracket form. And so x remains as x, because x minus 0 is just x. Then we have x plus 1, and then we have x minus 3. And then from the bracket, we go to determining whether they are linear or quadratic. And so to work this part out, we just need to look at the nature of those points. So we can see that there's a quadratic solution at x plus 1, whereas at x is equal to 0, there's a linear one, and so is there a linear one at x equals to 3. So this remains as x. This here is the one that turns, so we need a square there. And then we have x minus 1. So far we can use these linear factors to determine what the equation of px is. So we need to have a dilation factor, x. You can just write it out like so. They're all multiplying. And then you have to choose a particular value that it seems like it crosses over. And a lot of the time in papers, they will give you a more accurate coordinate, but I'm just going to choose this one. So this coordinate here looks like it's at 1, and that coordinate there looks like it's 2, 4, 6, 16. Okay, so that's sub in 1 and 16 into your equation here. So you can go 16 equals to a times by 1 plus 1 squared, and then 1 minus 3. So 16 equals to a, that's 2 squared, which is 4. That's negative 2. That's negative 8. Negative 2. So our polynomial is px equals to negative 2x that is our polynomial. Okay, so far we've got the polynomial written. The second part of this question is, give the formula of px if the following transformations take place. So now we're trying to transform. So whenever we do that, we have to look at, first of all, we have to build equations that relate x dash to x, which is the image to the old x value, and likewise for y, doing the same thing. So it says dilation factor of 2 parallel to the y-axis. So what's happening there, if you have a dilation factor of 2 parallel to the y-axis, if you have a point and it's going that way, that's a dilation of 2 parallel to the y-axis. So in other words, you're actually influencing your y values. So we'll take our image. We'll say the image, to obtain our image, we have to go 2 times the old y value. Now, we then reflect around the y-axis. So that's, if we take a point and we rotate it and put it right there, we put it right here, okay, we have actually reflected it around the y-axis. So reflection around the y-axis is actually a change in the x value. So we put a minus in front of our old x value. And then we have a translation of 1 unit in the positive horizontal direction. So if we're moving by 1 unit in the positive horizontal direction, we're adding 1 to that. So now what we do is we will rearrange y dash in terms of y and so what we're going to do, y is equal to y dash over 2 and x is equal to x dash x dash minus 1 over negative 1, which is this. Okay, so now finally we have to just replace our old, what we're going to do is let px equal to y, and then we just go, okay, well, the old equation was this. Now we're going to replace that with the y dash over 2. Okay, and we multiply the other side, this by negative 4. And that becomes negative 2. So our final stage would be just to clean up the equations. So what you can do to make this neater is to take out the negative from there, and remove the negative entirely from here, outside of the bracket. So I'm just factorizing it out. Now, because this is a negative and there is a square there, that's going to completely go away. Whereas this negative 1 and this negative 4 are going to multiply by each other, giving you a positive value. So positive 4, x dash plus 1, so we get that, and then we just say, therefore, the new function, so maybe you want to call the transformed function g of x, where you always have to define these kind of changes, where, q of x is equal to y dash. So we can now remove the dashes and just get something like this. So that's our transformed function.